Hi guys, today we're going to be taking notes on page 15 in our ISN on rational numbers. We're going to go over some vocabulary first and then review how to turn fractions into decimals, then decimals into fractions. Let's get started. Well, first of all, what's a rational number? Well, a rational number is basically any number that can be written as a fraction, such as a over b, right? Any number that can be turned into a fraction where b can't be 0, because remember, we can't have a 0 in the denominator place. And a and b are both integers. Well, for example, 0.7, sorry, there you go, 0.7 is an example, 8 is a whole number example. All of these numbers right over here, 3/8, negative 0.72, all of those numbers can be written as a fraction. An irrational number, however, cannot be written as a fraction. A pi, or pi, is a good example, and square root of 2. Neither of those numbers can be written as a as a fraction, so that is why those are irrational numbers. A couple of other words, terminating decimal and repeating decimal. A terminating decimal only has a finite number of decimals places, so 0.6893. It ends right there, right? We know where it ends, so that's a terminating decimal. And then repeating decimal is a block of one or more digits that repeats or continues indefinitely. Example is 0.06, where 6 just repeats over and over, because remember, we know this line over the 6 tells us that 6 is repeating over and over. And then 0.45, again, that line over 4 and 5 tells us that 0.45454545 both are repeating indefinitely. Okay, let's go over an example for how to turn fractions into decimals. 1/5 is our first example. What we're going to do is we're going to take our numerator and put it inside of the house, and denominator and put it outside of the house. Well, does 5 go into 1? Nope, it's too big, so we're going to have to add some zeros. But first, we have to put that decimal in there before we start adding zeros. So now, does 5 go into 10? Well, yes, it does, right? 5 times 2 gives us 10, and when you subtract it, you get a 0. So perfect. Our answer for 1/5 is 0.2, or 1/5 equals the decimal 0.2. Go ahead and do example 2, or turn 3/8 into a fraction, or into a decimal. Use your division, put your numerator on the inside and denominator on the outside. Okay, example 3, 4/9, the same thing. We're going to put that numerator on the inside, denominator on the outside. Does 9 go into 4? No, it does not. It's too small, so we're going to have to add that 0 in there, but before we do, we have to put in that decimal. Well, does 9 go into 40? It does. When you multiply 9 times 4, you get 36. Perfect. So let's do that subtraction. 3, 10, remainder 4. Uh-oh, we're going to have to add another 0, right? How many times does 9 go into 40? 4 times. Uh-oh, we might be seeing a pattern in here, right? That 4 just keeps repeating. We keep getting the 4 remainder, and then we add that 0 to get 40. So we know now that the answer to 4/9 is 4, or 0.4, where 4 is repeating. Go ahead and do the same thing to example 4. Turn that fraction into a decimal by dividing your numerator by the denominator. Write each decimal as a fraction. Now we're getting into turning decimals into fractions. The way to turn decimals into fractions is you're going to say, okay, well, how many spots after the decimal is my furthest digit? Well, 5 is furthest from the decimal, and it's in the hundredths spot, right? So because my 5 is in the hundred spot, we're going to take 65 and put it over 100. And then you're going to reduce like normal. We're going to divide both the numerator and denominator by 5, which gets you 13 over 20. If you want to check, go ahead and pause the video and you can do the math. Example 6, right over here, go ahead and do that on your own. What is 5 in? What spot is that in? Well, remember, this is tenths, 100ths, and 1000ths. So you're going to put that over 1000 and reduce like normal to get your final answer, what your fraction is supposed to be. Okay, so now that we have repeating decimals, it gets a little trickier how to convert repeating decimals to fractions. We're going to start with letting our decimal equal to x. So we're going to let x equal to 0.7, where 7 is repeating. So we have x is equal to 0.7. And just like previously, well, let's look. My number furthest from the decimal place is in the tenth spot. So instead of putting my decimal over 10 as a whole number, we're going to, or not as a whole number, but after taking away the decimal point, we're going to actually multiply both sides by that 10. So multiply x by 10 and multiply 0.7 by 10, because remember, whenever you do one thing to one side, you must do the same exact thing to the other side. When you multiply this out, you end up with 10x is equal to 7.7, where 7 is repeating. Okay, we just multiplied 0.7 repeating by 10. Okay. So now our goal here is to get rid of all this stuff, all this repeating stuff, because that's the hard part. So how do we do that? Well, let's just take an x off, because remember, x is equal to this repeating stuff, or 0.7 repeating. So when we subtract x from one side, well, we must do it to the other side, but we know x equals 0.7 repeating, right? So you subtract 1x from this side and end up with 9x is equal to, well, 7.7 repeating subtracted by 0. Let me write that out a little better so you can see where I'm working. 0.7 repeating. We're going to subtract this because remember, that's the statement we made clear at the beginning. X is equal to 0.7 repeating. So we're going to subtract that from this side. When you subtract it, you end up with just a 7. Now, in order to get our x by itself, we're going to divide both sides by 9, because you know when you have a number next to a variable, it's being multiplied. So 9 over 9 gives us a 1x, or an x is equal to 7 over 9. And that is how you turn your repeating decimals into a fraction. It's trickier, but it gets the job done. Another a shortcut way to do it, guys, is to see, well, there we go. Let's say we have 0.65 repeating. What you can do, the shortcut, is to take our 6 and 5 and put it over that many 9s. So we have 2 digits behind the decimal place. Well, we're going to take 2 9s and put it over 2 9s. Right? Okay. Go ahead and give this example a try. I would like you to use this method. Okay, I want to see this on your page when we come back to class next time. Do the same exact method. Let x equal to 0.48 repeating. And remember, my 8 is in the hundreds spot. So instead of multiplying by 10, you're going to multiply by 100. X is equal to 0.48 repeating. Multiply this by 100, and then follow these exact steps. Get rid of that repeating part by subtracting 1x from this side, and then 0.48 repeating from this side. Okay, good luck, guys. See you next class.